We're talking about a discovery that literally rewrites the timeline of the early universe. NASA has just confirmed that the James Webb Space Telescope has identified the earliest supernova ever detected, an explosion of a massive star that occurred when our universe was a mere 730 million years old. To put that in perspective, that is only 5% of the universe's current age. This isn't just a new record, it is a total disruption of what we thought we knew about the cosmic dawn. Today, we're going to break down how this happened, the global hunt that led to this moment, and the scientific mystery that has astronomers shocked. The story of this discovery, designated GRB 250314A, didn't actually start with Webb. It began as a high-stakes international relay race across the globe and through orbit. On March 14, 2025, an alert chimed in control rooms across the world. The SVOM mission, a Franco-Chinese telescope launched in 2024 to find fleeting transient events, detected a gamma-ray burst, GRB. This was a super bright flash of light that lasted about 10 seconds. In the world of high-energy physics, a 10-second burst is a long-duration burst, and these are almost always the death cries of massive stars collapsing into black holes or neutron stars. Within just 90 minutes, NASA's Swift observatory swung into action, pinpointing the exact X-ray coordinates of the source. Then, 11 hours later, the Nordic Optical Telescope in the Canary Islands detected an infrared afterglow, a telltale sign that this object was incredibly far away. 4 hours after that, the Very Large Telescope in Chile estimated the distance. We were looking at an event from the first billion years of time itself. But here's where the strategy gets fascinating. Astronomers didn't point Webb at the source immediately, they waited. You might wonder, if you find the earliest supernova in history, why wait until July 1st, 3.5 months later, to use your best telescope? The answer lies in the fundamental physics of an expanding universe. As light travels across billions of light years, the expansion of space stretches that light. This is called cosmological redshift. But it doesn't just stretch the light, it stretches time itself from our perspective. While a supernova might brighten and dim over a few weeks in the local universe, for an object this distant, that process is slowed down significantly. The research team, led by Andrew Levon, used a rapid turnaround program to catch the supernova exactly when it was predicted to be at its peak brightness. Webb provided the sensitive follow-up that no other instrument on Earth or in space could achieve, proving it can find individual stars at the very dawn of time. Before this discovery, the reigning champion for the earliest supernova was an explosion that occurred when the universe was 1.8 billion years old. Webb has now shattered its own record by more than 1 billion years. This is a monumental leap. We are no longer just looking at the teenage years of the universe, we are looking at its infancy. In the last 50 years of astronomy, we have only found a handful of gamma-ray bursts from the first billion years. This event is, in the words of the researchers, very rare and very exciting. Now, let's get into the part of this news that is sending ripples through the scientific community. When the team analyzed the data from Webb's instruments, they expected to see something alien. The early universe was a different place. It was the era of reionization, a time when the gas between galaxies was opaque and thick. These early stars were expected to be massive, short-lived, and lacking the heavy elements, like carbon, oxygen, and iron, that later generations of stars, and we, are made of. However, when they looked at the results, Webb showed that this ancient supernova looks exactly like modern supernovae. This is a shocking similarity. How is it possible that a star dying 13 billion years ago looks identical to a star dying in our neighborhood today? It suggests that the processes of stellar death were perfected by nature much earlier than we previously thought. Scientists are now combing through the data to find tiny differences that might explain how these early stars managed to look so modern so quickly. Perhaps the most visually impressive part of this discovery, if you know what you're looking at, is the detection of the host galaxy. Using Webb's near-infrared camera, astronomers were able to see the galaxy where this star once lived. In the images, It looks like nothing more than a reddened smudge of a few pixels. But don't let that fool you. Identifying the galaxy at this distance is a major breakthrough. It appears to be a typical galaxy for that era. But now that we know where it is, the team has a new strategy. They plan to use the afterglow of future gamma-ray bursts as a fingerprint. By watching how the light of the explosion passes through the gas of the galaxy, Webb can read the composition of the galaxy itself, revealing the secrets of the first structures ever formed in the cosmos. This discovery proves that Webb is more than just a deep-field camera. It is a precision tool for time-domain astronomy, the study of things that change quickly in the sky. By coordinating with missions like SVOM and Swift, Webb is part of a growing worldwide network that acts as a planetary defense and exploration system. We are moving into an era where we can track the life and death of individual stars across the entire history of time. We aren't just looking at galaxies anymore. We are looking at the citizens within those galaxies at 5% of the universe's age. Imagine you are looking at a photo album of your great-great-great-grandparents. You expect them to look completely different, perhaps wearing strange clothes or looking like a different species entirely because they lived so long ago. But when you look at the photo, they are wearing the exact same modern t-shirt and jeans you are wearing today. That is the shock astronomers felt when they saw this ancient supernova. It looked exactly like the modern stars we see in our own backyard. Thanks for watching our deep dive analysis. And please do like, subscribe, and hit that notification bell so you never miss a Webb discovery. We are living in the golden age of astronomy, and we're glad to have you along for the ride. See you in the next one.